Hey everybody, welcome back to the Nidus Anarchy series. I'm your host, Adam, CIO, co-founder of Nidus, and today I have Josh Benaron of Irys, actually out of Dubai right now, so that's pretty awesome. Thanks for joining us. I want to talk to you about provenance because digital provenance seems to be something that everyone is going to absolutely need with the rise of AI, I feel. So could you kind of give me a background of you and your company and kind of what you guys do?
Yeah, sure. So, first of all, I'm Josh, founder CEO of Irys. Personally, I got into the world of, I'm an engineer. I got into the world of crypto about 4 years ago. I was studying computer science at a university in the UK, and I'd been working on some open source databases and kind of lower level stuff, and
Hmm.
ended up getting into crypto. Really fell in love with the vision of crypto, but specifically in the world of decentralized storage and having and the general idea that you can have this censorship resistant information layer for all of human history was this very powerful vision that I just fell in love with straight away. And specifically, I was working kind of closely in the world of Arweave. So Arweave is this permanent storage protocol. The idea is that you kind of pay a one-time fee and the data is stored forever. And there are a bunch of reasons it's quite powerful, but the original kind of vision that I saw personally on my side was I kind of looked at where humanity is going to be in 100 years' time, and the idea
That
that
is
we could
far
have
out.
this. Yeah. And this is exactly how I think. And it was what seemed very powerful to me is that with this kind of technology, you would be like humanity would have this perfect depiction of history for the first time ever. So if you look at the last millions of years, we're always guessing roughly what happened, and the technologies have improved over time, but we'll never have a good understanding of history. But now we're looking at a future where we could have basically all data recorded, from now to 100 years time,
Yeah.
and we're going to be able to have like the history book will be 100% accurate. That's kind of how I look at it, and that was kind of the original um, thing that got me into the world of
So let me
decentralized
ask you
storage
this
in the
though.
world
You
of
said
in the
the
world of
history book is
crypto.
going to be accurate. So I always love the quote, the history books are written by the winners. So, and your whole thing here is about provenance, right? So I would imagine you are kind of saying, look, yeah, the digital data is the history book, but you're there to say, well, what was actual real and what is someone making up or has been altered?
Right. So we actually spoke about this internally, and we were like, okay, we're not a truth layer. Like we're not saying this is true and this is not true. We're
Mhm.
just saying, look, this kind of information was created by this person this time, and you can just
Gotcha.
know that it was actually created by in this kind of under these parameters.
Hmm.
But the idea is that kind of in the future that really history is just you just need to have as many inputs as possible to decide, okay, what is your version of history. So
Right.
you're right, there's always going to be confusion around what happened in the past, but now we're looking at a future where we'll have all of the inputs, we'll understand both sides of the argument, so to speak. Whereas before, you're right, it used to be hundreds of years ago, the winners of these battles would kind of talk about how amazing their warriors were,
Right.
and they wouldn't talk
And
about
just
how
burn the history books
fantastic
of the
perhaps
other
the
people.
right. So I remember learning this when I was younger. It was kind of fascinating to me. So yeah, so when I got into the world of crypto, this was kind of the thing which really made me fall in love with it. And to this day, this is kind of one of the visions that really excite me.
So how does Iris do provenance for data? What's kind of like the technical
Yeah.
like background there?
Yeah. So jumping into Iris, and just to tell the quick story, Iris was launched in kind of August time 2021, and originally it was essentially a scaling solution for this blockchain called Arweave. So Arweave is essentially this permanent file system, and it could only do 8 writes per second, which a good mental model for that is like if we all shared a computer and we could only write to a directory. 8 people could only write to a directory globally out of the 8 billion people that exist. So it wasn't a particularly scalable system at that time. And our goal back then was, okay, this vision of this technology is very cool, but how do we make this more scalable such that anyone can use this thing permissionlessly? So that's what we originally launched, and then we took Arweave from doing 8 TPS doing thousands of transactions per second, and it can kind of scale arbitrarily. So the foundation initially for Irys was scaling this permanent data layer. And I guess taking a step back, the way I talk about provenance is there is kind of strong and there is weak provenance.
Okay.
And strong provenance, and how we talk about strong provenance, is there are really three pillars there. There's permanent, precision, and unconstrained, or constraint in general. So permanence is important because provenance is really just about verification. It's about understanding something in the past. And the question is, in 20, 30, 100 years time, are we going to want to verify something 100 years prior? The answer in my mind is obviously yes. So this idea of permanence is very important. And then moving to precision, it's about, is the information that has been stored kind of precise? And again, it's not about telling the truth. It's about, okay, is this timestamp accurate? Do we know it was from this period of time? Do we know it was published by this person from this location, etc.? So just having context around information is one of those core pillars, and being able to trust that context. And then the final point is about being unconstrained. Again, it's kind of one of the big visions of crypto more generally. It's about being permissionless and allowing anyone to participate. And really what that means for provenance is like anyone can write to these provenance systems, anyone can read from them, and anyone can verify them. And you shouldn't have gatekeepers around this. It's almost like a human right. It's kind of the way that we do it. So like tying this into Irys specifically to get to your question. So the permanent side we inherit from Arweave, and the unconstrained component, by scaling Arweave, we inherit a lot of the scalability that we built upon initially. So anyone can, anyone can write to Irys. So we scale to tens of thousands of transactions per second, and also anyone can read as well. And the cool thing is that this information is all public, so anyone can verify this information as well.
So what's the difference between Arweave and IPFS?
Oh, great question. The answer is they're very different. So different, in fact, that you can use both of them together. So Arweave is a storage layer. So the best mental model is all it does is it stores information, ones and zeros. And IPFS is actually known as a content addressing layer. So what that means essentially is it is just a way of mapping an ID to some storage layer. So if you look at it from like a stack perspective, you have a storage layer, which is just storing the ones and zeros, and then you have an addressing layer, which is kind of this way of labeling information. So the idea behind So IPFS pinning is like the pinning component is typically an IPFS node connected to some centralized server, but the actual storage layer is the server. The IPFS is just actually the addressing layer. So it's not IPFS doesn't provide any guarantees around storage.
Okay, nice. Okay, so that makes sense. So then it's kind of like the file pointer system, but it's not the actual file storage itself. Like on the hard drive, you just points to where the file is. When you erase it, you're really just erasing the addressing marker. You're not actually erasing the actual underlying file storage part.
Correct. Yeah, and actually, I mean, operating systems don't even clear the data; they just kind of mark it as can be overwritten. Available, right? So they don't even kind of delete it, because deleting it would be essentially zeroing out information. And hard drives don't even do that. You're right.
Cool. So so from a provenance perspective, so let's say that's technically, what are you doing? Like, what's a business use case that your typical client uses, and then what's the benefit that you're offering to them that they're like, I want that?
Sure. So we work across several verticals. Most of them are crypto native in some form. So on the first use case we actually initially started was NFT. That was actually our initial rise. And we were the main storage layer, basically the way to store a lot of the JPEGs back in 2021 when Solana was get big and NFTs were big. And we did about 92% of Solana's NFTs during that period. So we were fairly prominent there. So that was the initial use case. But when we're talking about provenance, I think that the more personally, the more interesting use cases are these kind of content use cases, right? Because what is the problem that provenance is solving? It's fundamentally allowing users to trust the information they see and verify that they can trust the stuff, right? So And that's all kind of content-based use cases. So whether it could be media, as in like traditional media, social media, etc. It could be anything, and obviously AI as well. So when it comes to kind of some of the users we have today, we work. So on the social side, we work with both kind of the social protocol level and also a bunch of social applications as well. So we've worked with the likes of Lens Protocol and CyberConnect, which are kind of these Web3 social protocols. But we also worked with a bunch of kind of smaller kind of social media applications. And the idea there is that the reason they do work with us, and I think they like working with us, is fundamentally they require the properties of strong provenance. They need permanence, they need precision, need some. If you think about like a Twitter feed, everything is timestamped and ordered. Like fundamentally,
Yeah.
these social apps are built upon provenance, be it a very centralized version. But when you're building a decentralized social media protocol or application, you want to have this information in some kind of decentralized hub. So one of the core features on the precision side is, or two features perhaps. One is timestamping on Irys is millisecond precise. So we essentially use an attestation protocol where every bit of kind of every transaction, every bit of information or data that comes into Irys is timestamped with a millisecond precise timestamp. So when we're talking about kind of the Lens protocol use case, it's okay. You have a bunch of these kind of social transactions or posts, and how do we order them at speed? Because again, one of Lens protocol's requirements was okay, we think that we could be this. Their vision is we want to be this decentralized, censorship resistant social media protocol for the world, right? And if you look at something like Twitter or sorry X, they did. I think their peak was 35,000 tweets per second or posts per second. During the World Cup, it was definitely 25,000 per second. But we're talking about fairly scalable systems there. We're talking about something that needs to scale to global demand.
Yeah.
And when these social protocols are working with us, we're really providing these three things. It always comes back down to these three pillars. I'm going to be like a broken record: permanence, precision in terms of the ordering and attribution of content, and then
Yeah.
unconstrained as well. It's okay, can this thing just scale? Like if we had a billion or million or however many users onboarded tomorrow, is the system going to survive? And
Yeah.
that's fundamentally the promise we provide. We give to our users.
So what is that data layer? Where's this data being stored at?
Sure. So all of the data is kind of settled, is probably the wrong word, but all of the data eventually settles to Arweave. So
Okay.
the way it functionally works is that data is posted to Irys, and then you're essentially trusting Irys for 3 minutes, and then beyond that, it just gets to Arweave. And at that point, it inherits every single decentralized property that Arweave has currently. So
So
yeah.
can other blockchain apps like Ethereum-based apps, Solana apps interact with Arweave file application systems? Or how's that kind of work?
So you can't interact with them from a smart contract, perhaps,
Okay.
because smart contracts, just VMs are highly restricted. But
Yeah.
typically, we work with a bunch of projects on the world of Solana and Ethereum. When it comes to NFT or social projects, it's usually a combination of this Web 2.5 approach where you basically have an application that has some touch points with a centralized server, or you're doing all of the Ethereum interactions and kind of Irys
Right.
interactions separately on the client side.
So is there a gas fee for posting a file, or is it like how's the fee work on that kind of system?
Yeah, so Irys's business model is a function of essentially Arweave's fee model. So let's say a gigabyte on Arweave is $1, making a number up, then
Sure.
we essentially just you're charging a margin on top of that, a small margin on top. But yeah, so you're paying per byte is kind of the
Okay.
mental model here. So for social posts, you're paying a very small number, a fraction of a cent. And then obviously if you're archiving, a petabyte of data, you're paying a lot more.
Okay. Interesting. The reason I asked, so I actually developed a social media platform that exists entirely on blockchain. It's running on Polygon right now. I haven't marketed it out to anybody. There's even a mobile app for it. It's really just for me to play with.
Oh, really?
But to give you an idea of the complexity, it's like around 30 contracts in size. And the entire thing, yeah, it's crazy. Like the level of complexity is insane on this thing. But it's 100% blockchain based. There's zero servers involved. no interact. And it can scale into the hundreds of millions for users and posts and everything else, all on Polygon. But one of the things it doesn't have is the ability to post content like pictures, videos, upload stuff, because you can't upload a picture really well to a blockchain. You could upload little sprites and things, but for all intents and purposes for social media, you can't upload a picture. And that was kind of the one big thing. Like, well, I could do IPFS pinning and then all this stuff. Then you got to pay for the pinning and all that kind of crap. So this is actually a really interesting system that you have, because that could work very well with this whole thing. Because and it's not like the one thing that drives me nuts about decentralized, when people throw the word decentralized around, and it's like, yeah, we have this decentralized model. It's run by these people that have these servers. Like, well, then we're no longer decentralized, then are we? It's like that kind of defeats the purpose. So this was developed as literally completely decentralized in the sense that I don't even have control or ownership of it anymore. So it's a monster that's out there and it can never be taken down. People's posts can never be censored. People's opinions are out there forever, but there's missing that data layer. So this would be kind of a very interesting proof point for that.
Yeah, and yeah, I mean that's kind of the Ethereum world computer messaging back in the day. And the cool thing with Arweave and therefore with Irys is that you can actually host static front ends as well. Because if your site is just a static, just a bunch of JavaScript and HTML, it's just files, and you can actually represent
right now the website version
well.
is
You can actually host that
IPFS. So yeah, it'll work the same way.
There we go. Right. Yeah. Same with IPFS. IPFS is IPNS, I think, which is the equivalent of or IPNS, which is the equivalent of like a directory structure. So yeah, all of these storage protocols have similar kind of ways of representing directories.
Interesting. Now, does Arweave, so doing a hosted site through Arweave, like, can I use your service to kind of be that middleware layer for interacting with the file system there? And then how does my browser then get to that? Because like I'm using Brave, so IPNS is kind of built in, or there's proxies. Is there similar stuff that leverages like the Arweave protocol?
Yeah. So a few things here. One, on the Irys front, we just from like a user perspective, we provide ways to essentially do high performance reading and writing both sides. So a lot of our users use it for both, because we provide kind of optimal performance in both directions. But kind of looking at Arweave more holistically, there is an R protocol as an AR ://. But browsers, I don't think support it yet. But it's been around for a few years. I just think browsers are typically slow to support it. But the general idea is that you all that really is all that really is in the background is that it's running some stuff in JavaScript, and just you're basically falling back to a bunch of different for IPFS gateways, for Arweave, it's a bunch of Arweave gateways. And the cool thing here is that it's totally redundant. So if you reference something using the R protocol, then you can have just a list of gateways. And even if one is down or one is censoring some information, then you can just fall back to another one. And this is roughly how IPFS gateways and the IPFS protocol works as well.
And what's the availability been like? Because I know, I mean, things like, has it been like 5.9s or has it been like Solana? Where it's just, and we're down. Like, what's kind of been availability for the data?
Always network has been pretty damn available. Yeah, I mean, not even close to Solana. It's a lot of nines. I don't know the exact, but it's a lot of nines.
Okay, cool. That's pretty rad. So is Irys is there REST interface? Is that what you're saying? It's kind of how apps interact with your service?
Yeah, so there are kind of two ways. There are kind of two components. There is one, the SDK, which is essentially just JavaScript, or we actually have it in multiple languages, but it's essentially an implementation of our transaction format. So when we actually created Irys back in the day, the first thing we actually did was create this kind of bundle spec, which allows you to which defines a new transaction format. And so the SDK essentially defines that format for you and provides with kind of nice APIs, so you don't have to write binary. And then yeah, we just have a basic kind of a quote unquote basic. It's actually not too basic, but a mildly basic to use REST API. And then it's kind of black magic, because in the back end, we're just kind of taking in data and then managing the data and making sure it gets onto the network correctly.
Cool. And is it immutable as well?
Yeah, I mean, we inherit all of the properties of Arweave, so it's totally immutable. So Every bit of data has a unique transaction ID, and every bit of data can be verified using that ID.
Yeah. So what are clients using it for today? As you're saying, like the Lens protocol for social, like what are some other use cases that people are using Iris for?
Yeah, we have, yeah, I mean, we work probably across 10 verticals. I'll list the top ones. So we've spoken about NFT, it's a big one.
Yeah.
We work across several ecosystems there. Social is actually probably the third or fourth biggest. The second biggest is actually archiving,
Hmm.
which is, and the more interesting use cases, and this is kind of one of my wider theses, is all of these proof of stake networks are essentially optimized for compute only. So if you look
Right.
at Solana, all it's really trying to do is, how fast can we go?
Yeah.
And I don't care how much data I produce. I just want to go as fast as possible. But there's a key caveat there. I don't mind how much data I produce. It means that there's this kind of huge state bloat, not just state bloat problem, but actually ledger bloat problem. So I think Solana is about 600 terabytes now, and well, at a max capacity, it generates, I don't know, about 5 petabytes a year. So it's generating a fair amount of data, and this data is important because if you want to replay the chain, if you want to verify, validators are being malicious or not, you need to be able to retrieve that data, replay it, and then check the current state. So one of my big, one of our big use cases right now is archiving ledger data for a bunch of different chains. And I think this is actually going to be a fairly large use case moving forward because everyone's moving to POS, everyone's performance optimized, Monad, Solana, we, Aptos, you
Yep.
name it, which means that there's going to be many petabytes of data being produced if you believe that crypto is going to win, which I assume both of us, both of us think that.
Have you worked with any type of enterprise clients, like larger businesses, like less Web3, more old school?
So in the world of the answers, the only enterprises we worked with are ones that have moved into Web3. So we briefly worked with Meta for a second, but the yeah, like in terms of actual web enterprise use cases, I'm going to make the case that it's not a good way of spending time for most Web3 projects. And when it comes to decentralized storage, it's actually very hard to compete with existing infrastructure providers. You'll compete with new functionality, and I'll come to that. But like the idea is that how are you going to compete with AWS when they have basically access to the cheapest hardware and
Yeah.
infinite amounts of capital, and they basically run everything at not everything at a loss, but they run a lot at a loss,
Yeah.
and they can do that as much as they want. So it's actually kind of like basic storage is kind of just a commodity. Where it becomes less of a commodity is when you layer on these more unique kind of Web3 value props. So like what does Web3 storage actually provide you? Well, censorship resistance, right? That's like the basic
Yep.
functionality that everything Web3 relates. Verifiability is the other interesting one, right? It's like, okay, what if you want to perform, okay, this is very abstract, but what if you want to perform X action if Y thing has been stored? Like how do you implement that in a decentralized way? So that kind of level of verifiability just doesn't exist in Web2 systems. So my very perhaps controversial view, because this is kind of goes against the Filecoins of the world, is that enterprise focus is actually not particularly exciting, and in 10 years' time won't be the big use case. It's going to be like these Web3 native verifiability focused use cases.
Nice. Very cool. So what do you have? What's kind of in the future for Iris?
Yeah, I mean, there's some stuff we can talk about, some stuff we can't talk about, but really in the short term, we do a lot of kind of small iterations and just improving on the product side, and we release something every month, like minor to big changes every month. And it's really just about optimizing the developer experience. So in isolation, these things are kind of small. Like we're just about to release a way for people to essentially approve balances and essentially kind of subsidize their use of storage. But month on month, we're releasing these incremental features, which kind of are 10x in the experience. Because the overall kind of vision for Iris initially was, well, not vision, but kind of goal for Iris was to be as product focused as possible and
Mhm.
just be as close to the user as possible and just understand what they want and build things that people want. So we've got a few things coming out that yeah, around kind of the developer experience improvements. But beyond that, I'm afraid you have to wait and see
Have to wait and see what
for some
happens.
stuff that we're
All
have
right,
to wait
cool.
for some stuff that we're cooking right now.
So if people want to reach out to you or sign up and check out the Irys, what should they do?
Yeah, I mean, uh, most basic one is Irys's website. You can take everything is linked there. So iris.xyz, irys.xyz. If you're interested in the technical documentation, then go to doc.iris.xyz. And if you want to go direct to the source, you can hop in our Discord and just speak to me. I'm kind of permanently online. Even when I'm asleep, my brain is plugged into Discord and Telegram. So I know when notifications are coming in. So our team is pretty available. So feel free to just ping us in either the Telegram or this Discord group, and I can even hop on a call. So
Cool.
we're pretty available.
Awesome, man. Well, hey, I really appreciate your time. You guys are doing some pretty cool stuff. It's pretty exciting to talk about.
Awesome, and I appreciate you giving me the opportunity to talk about it.
Hey everyone, you going to Identiverse this year, May 28th and 29th in Las Vegas? We're going to be there, and we're going to make it awesome. How? We're having a scavenger hunt where you can win awesome prizes and cool fun stuff like an invite to our private party. The way that you're going to find it is find these little poker chips all over the convention, tap your phone to them, and that's how you're going to start the scavenger hunt. Lots of cool prizes, and not everyone's going to be able to make it. Hope you can do it. I'll see you guys there. Later.